Hey everyone, and welcome back to the channel. Today we're diving into the life of a true giant of history, a man whose courage and curiosity literally changed the way we see the universe. I'm talking about Galileo Galilei, often called the father of modern science. His story is more than just stars and telescopes. It's a thrilling tale of discovery, conflict, and a relentless pursuit of truth. So grab a seat, and let's journey back to Renaissance Italy. Galileo Galilei was born in Pisa, Italy, in 1564. His father was a famous musician, and initially Galileo was pushed towards a more practical career, medicine. He enrolled at the University of Pisa to become a doctor. But something else captured his imagination. It wasn't human anatomy. It was the world of mathematics and physics. He was fascinated by how things moved, why they fell, and the elegant, predictable laws that governed the world around him. One famous story, though maybe not entirely true, tells of him watching a swinging chandelier in the Pisa Cathedral. He supposedly used his own pulse to time its swings, and discovered that the time it took for a pendulum to swing back and forth didn't depend on how wide the swing was. This was the kind of observation that set his mind on fire. He soon dropped out of medical school, much to his father's dismay, to become a mathematician and philosopher. It was a risky move, but it was the first step on a path that would reshape our understanding of the cosmos. Early in his career, Galileo was a respected but not yet revolutionary professor. He taught mathematics, first in Pisa and then at the prestigious University of Padua. He was brilliant, but his early work focused on practical problems and inventions. He developed things like a geometric and military compass, a tool that was incredibly useful for gunners and surveyors. He was a practical inventor, a tinkerer, and a brilliant teacher. His lectures were so popular they had to be moved to larger halls to accommodate all the students. But the real turning point, the event that would seal his legacy, happened in 1609. News reached him of a new Dutch invention, a spyglass that could make distant objects appear closer. But what he did was arguably more important. He heard the description of this new device, and with nothing but his understanding of optics and a bit of trial and error, he built his own. And then he made it better, much better. His first telescope magnified objects 3 times. His next, 9 times. Within months, he had a telescope that could magnify things 30 times. But the most crucial thing he did wasn't just building it. It was what he decided to do with it. Instead of just pointing it at ships at sea or distant armies, Galileo did something no one had seriously done before. He pointed it at the night sky. And what he saw was breathtaking. It shattered a worldview that had stood for over 1,000 years. For centuries, everyone believed in the Ptolemaic model of the universe, which placed the Earth at the very center of everything. The sun, the moon, the planets, and the stars all revolved around us in perfect heavenly spheres. The celestial bodies were thought to be smooth, perfect orbs. But Galileo's telescope revealed a very different, much messier, and far more interesting reality. First, he looked at the moon. It wasn't a smooth, polished sphere at all. It was covered in mountains and valleys, craters and plains, much like the Earth. This was a radical idea. It suggested the heavens weren't some perfect, ethereal realm separate from us. They were made of the same kind of stuff as our own world. Then he turned his telescope to Jupiter. He saw what he first thought were 3 small, faint stars near the planet. But as he watched night after night, he saw they were moving, and they weren't just wandering aimlessly. They were orbiting Jupiter. He discovered Jupiter's moons, which we now call the Galilean moons in his honor. This was a bombshell. Here was clear, undeniable proof that not everything in the universe revolved around the Earth. Other celestial bodies had their own satellites. He also observed the phases of Venus, just like our own moon's phases. This could only be explained if Venus was orbiting the Sun, not the Earth. When Venus was on the far side of the Sun from us, we'd see it fully lit. And when it passed between the Sun and Earth, we'd see its dark side. He saw that the band of the Milky Way wasn't just a cloudy smear in the sky, but was composed of countless individual stars. He even observed sunspots, blemishes on the supposedly perfect surface of the Sun, and by tracking them, he deduced that the Sun itself was rotating. Galileo published his findings in 1610 in a short book called Sidereus Nunquis, or the Starry Messenger. It made him an overnight sensation across Europe. He was hailed as a genius. He was appointed as the chief mathematician and philosopher to the Grand Duke of Tuscany, a position that gave him more freedom to research. He had seen the evidence with his own eyes. The old model was wrong. Now the sun, not the earth, was the center of our corner of the universe. This model, proposed decades earlier by Nicolaus Copernicus, was no longer just a mathematical theory. Galileo had provided the observational proof. But this new vision of the cosmos put him on a collision course with one of the most powerful institutions of the time, the Catholic Church. The Church's doctrine was deeply intertwined with the earth-centered model. It was seen as consistent with Scripture, and to challenge it was to challenge the authority of the Church itself. Initially, the Church was actually quite interested in Galileo's findings. Many Jesuit astronomers confirmed his observations. But as Galileo began to argue more forcefully, not just for his observations, but for the Copernican system as physical reality, the opposition grew. He was a brilliant scientist, but he could also be proud and argumentative. He wrote in Italian, not Latin, to reach a wider audience beyond academics, which made his ideas even more threatening to the establishment. In 1616, the Church officially condemned the Copernican theory, declaring it foolish and absurd in philosophy, and formally heretical, since it explicitly contradicts in many places the sense of holy Scripture. Galileo was warned not to hold, teach, or defend the theory in any way. For a while, Galileo stayed relatively quiet on the matter, but he couldn't let it go. He believed he was right, and the evidence was on his side. Things came to a head in 1632. A new pope, Urban VIII, who was actually a friend and admirer of Galileo, was elected. Galileo thought he saw an opportunity. He got permission to write a book discussing the two chief world systems, the Ptolemaic and the Copernican. The only condition was that he had to treat the Copernican view as a hypothesis and not declare it as fact. The result was his masterpiece, Dialogue Concerning the Two Chief World Systems. The book is structured as a conversation between three men. One argues for the Copernican system, another argues for the Ptolemaic system, and a third is an intelligent layman. The problem was, Galileo made the character arguing for the Church's Ptolemaic view, named Simplicio, which means simpleton in Italian, seem like a complete fool. The Pope felt personally mocked and betrayed. The hammer came down hard. In 1633, Galileo, now nearly 70 years old, was summoned to Rome to stand trial before the Inquisition. He was found vehemently suspect of heresy. Faced with the threat of torture and a painful death, he was forced to kneel and formally renounce his beliefs. He had to publicly state that the sun goes around the earth, the very idea his own discoveries had proven false. Legend has it that as he rose to his feet, he muttered under his breath, "Eppur si muove," which means, "and yet it moves." It's a great story, but probably not true. What is true is that he spent the rest of his life under house arrest. But even under house arrest, blind in his old age from years of staring at the sun through his telescope, Galileo's spirit was not broken. He went back to his earlier work on mechanics and motion, and in his final years he wrote another one of his greatest books, Discourses and Mathematical Demonstrations Relating to Two New Sciences. This work laid the foundation for the science of dynamics, the study of how objects move, and it directly inspired Isaac Newton's laws of motion decades later. Galileo died in 1642. It took the Church over 350 years, till 1992, to formally admit that they were wrong, and Galileo was right. But history has long since delivered its verdict. Galileo was a hero of science. He wasn't just a brilliant observer. He was a champion for a new way of thinking. He taught us that we shouldn't rely on ancient authority or dogma. Instead, we should look at the world, experiment, observe the evidence, and follow it wherever it leads, no matter how uncomfortable the truth might be. His life is a powerful reminder that one person's courage and curiosity can truly change the world. Thanks for watching, everyone. If you enjoyed this journey into the life of Galileo, please hit that like button and subscribe for more stories about the people who shaped our world. Let me know in the comments who you'd like to see me cover next. See you in the next video.